Hello guys, welcome to Abstronic tutorial. Now let me explain how the latching switch circuit working by just pressing the momentary switch to turn on and off. To relate to the latching switch circuit, we should understand how the internal circuit of the NE555 timer IC working and also the output signal at pin 3. So right now, let's go back to the internal block circuit diagram of the NE555 timer IC. Now, we have an internal circuit block diagram of the NE555 timer IC. As you can see, we have two comparator 1 and comparator 2. So let me explain first the comparator 1, then the comparator 2. We have two input and one output. The threshold input directly connected to the positive from the external circuit at pin 6. And the other one is 2/3 VCC directly connected to the negative input. Since the VCC is 5 volt, so therefore 2/3 of the 5 volt is equivalent to 3.33 volt. Right now, the threshold voltage is 0. To activate the output of the comparator 1, the positive input must be greater than the negative input. Since the positive input at pin 6 is 0 and the negative input is 3.33 volt, which is greater than 0 volt, so therefore the output is low. So when the output of the comparator 1 is low, the flip-flop circuit output at Q automatically high, which is the opposite of the output of the comparator 1. Again, to activate the output of the comparator 1, the positive input must be greater than the negative input, 3.33 volt. So let's inject 3.5 volt to the positive input at pin 6. Now, the positive input at pin 6 is 3.5 volt, which is greater than 3.33 volt. So therefore, the output right now is high. When the output is high, the flip-flop circuit automatically reset and the output at Q will be low. Now, let's review the comparator 2. Also, we have two input and one output. Trigger input directly connected to the negative at pin 2 and 1/3 VCC is the positive input. So 1/3 of the VCC, which is the voltage is 5 volt divided by 3, equivalent to 1.66 volts. Right now, the trigger negative input is 0 volt. So the positive input, which is 1.66 volt, is greater than the negative input, which is 0. So therefore, the output is high. So when the output is high, the flip-flop circuit automatically activate the set, and the Q bar output automatically low. So when the output at Q bar is low, so the discharging transistor right now is cut off, simply because the output at the Q bar is negative signal, attracting the positive charges at the base of the transistor. And the output right now is high. So let's go back to the latching switch circuit. The two output signal at pin 3 is positive and negative. So when you turn on the main switch of the latching switch circuit, the normal output of the circuit is negative output. Any positive charges from the capacitor will be discharged simply because the capacitor connected to the negative output at pin 3. When I press the momentary switch, what happened to the circuit? The 2N terminal of the switch will be shorted just for a moment. So when it's shorted, pin 2 and pin 6 and 2.5 volt will be grounded because it will connected to the negative output at pin 3. So therefore, 2.5 volt right now will be 0. Then 0 voltage will be injected at pin 2 and pin 6. Now, let's bring 0 voltage to the internal circuit block diagram of the NE555 timer IC injected at pin 2 and pin 6. Pin 2 and pin 6, they are connected together in the latching switch. Now, let's begin from comparator 1. Since the internal positive input is 1.66 volt, which is greater than the negative input at pin 2, which is 0 volt, so therefore the output right now is high. When the output is high, the flip-flop circuit automatically activating the set, and the output at Q bar is low. So when the output at Q bar is low, the discharging transistor right now is cut off, simply because the output at Q bar is negative, which is attracted the positive charges from the base of the transistor. The output at pin 3 is high. Now, let's explain the comparator 2. The internal negative input of the comparator 2 is 3.33 volt, which is greater than the positive input at pin 6, which is 0 volt. So therefore, the output of the comparator 2 is low. So when the output is low, the flip-flop circuit that is set not activated, so the output at Q bar and Q is remain their output. Now, let's bring again 0 volt to the latching switch circuit and injected at pin 2 and pin 6, and let's see if the output of the latching switch circuit is high. So let me try press again the momentary switch. Now you can see the output at pin 3 is high and the light emitting diode right now is glowing. Therefore, it was proven that the previous explanation of the latching switch circuit and the internal circuit block diagram of the NE555 timer IC, it was right that the output is high. And when the output was high, the positive output charging 1 microfarad capacitor via a 100 kilo ohms resistor. When the capacitor fully charged, it will not accept any positive output at pin 3. Since the positive output is 3.77 volt at pin 3, so therefore the capacitor voltage also 3.77 volt. So what happened to the circuit when I press again the momentary switch? When I press again the momentary switch, the 2-end terminal will be shorted, and when the 2-end terminal shorted, the voltage from the capacitor will be add to 2.5 volt, and these two combining voltage will be injected at pin 2 and pin 6. 3.77 volt plus 2.5 volt is equivalent to 6.27 volt. Now, let's bring 6.27 volt to the internal circuit block diagram and injected at pin 2 and pin 6. And let's see what happened to the output of the circuit. Now, let's go back to the internal circuit block diagram. Pin 2 and pin 6, they are connected together, and 6.27 volt will be injected to both comparator. Now, let's begin from comparator 2. 1.66 volt injected to the positive input from the internal circuit of the comparator 2, and negative input will be injected 6.27 volt at pin 2, which is the trigger. Since 6.27 volt is greater than the positive input 1.66 volt, so therefore the output of the comparator 2 right now is low. So when the output is low, the flip-flop circuit, the set not activated, and the output at Q bar is high. So when the output at Q bar is high, the discharging transistor right now will be activated simply because the output at Q bar is high, which is positive output injected to the base of the transistor, so that the discharging transistor will be forward biased. And the output right now is low. So even the output right now is low, still we need the output of the comparator 1 must be high in order to reset the flip-flop circuit, simply because right now the latching switch circuit is high. So when the reset of the flip-flop circuit activated, the output of the latching switch from high then turn to low. Now, let's discuss the comparator 1. Since the negative input of the comparator 1 injected by 3.33 volt, and also the positive input at pin 6 injected by 6.27 volt. And now let's compare the two input of the comparator 1. 6.27 volt is greater than the negative input, which is 3.33 volt. So therefore, the output of the comparator 1 right now is high. So when the output is high, the reset of the flip-flop circuit will be activated. So therefore, the output of the latching switch will turn to low. This time, the output of the latching switch circuit is going back to the normal, which is the negative output or simply low. Let's compare the result of this circuit to the latching switch, and let's see if the output of the latching switch circuit turned to low. So right now, let's going back to the latching switch circuit. Now, let's press the momentary switch and let's see if the output turned to low. You can see the output is low. Now, let me show you the latching switch on my breadboard circuit. Let's press the momentary switch.